Chuck, I got a new topic for you.
Uh-oh. Excellent.
Yep. What do you mean, uh-oh? What's that supposed to mean?
That means I'm ready. I always enjoy.
That means you're a little scared.
No. For me, uh-oh doesn't mean scared. I'm like, uh-oh, like, all right. So I don't use uh-oh properly.
Okay.
Clearly, I'm not using uh-oh in its proper form.
If someone says, "Oh, something bad is about to happen,"
yeah, you know what? And you know what? I'm gonna have to stop doing that. So
okay.
Now I know what the problem is. Every time I say "uh-oh," and people are like, "What?" And I'm like, "Nothing."
All right. So consider a few things. I want to talk about life. And
okay.
Yeah, it's relevant, and on size and life.
Well, listen, the way I see it is this, okay? Size is a preference thing, okay? And not all of us can actually, be what some people might have as a preference. And, why are you looking at me like that? Because why? Perhaps you've been told something about, my ethnicity, and maybe I'm supposed to be a certain way. Well, it doesn't necessarily happen that way for every person in my position and someone who looks like me.
We are eyewitness to Chuck digging himself out of a box. That's what that is. Okay. So here we go. So
go ahead.
You're in a room there, right? All right. It looks like a hotel room. All right. You can walk around on the floor.
I can.
Okay. If there were an ant walking around on the floor, it would be doing just what you're doing.
Absolutely.
However, an ant can go to the wall and then just walk up the wall.
Right.
How come you're not walking up the wall?
Because I'm not Spider-Man.
Okay.
That's all. If I were Spider-Man, I'd be walking up the wall.
Okay, because Spider-Man is imitating a spider.
Yes, he is.
Okay. But there are no spiders the size of humans.
This is true.
That can just walk up the wall.
Correct.
All right. There's a reason for that. There's a very good reason for it. And it has to do with the physics of life. Nobody ever talks about it that way. People say, oh, it's the biology, this. You can talk any biology you want. At the end of the day, physics sets the rules.
Take that, biologist. Here's a little smackdown for you, you biologist. Physics sets the rules, even in your world.
Physics. All right. So it all comes down to this.
Go ahead,
Chuck. Okay. So, how strong are your limbs? Well, the strength of your limbs is measured by the cross-sectional area.
Oh, God.
All right. So that tells you how big your muscles are.
Well, you're just embarrassing me on every level today. First, we're talking about size. Now we're talking about skinny wrists. Thanks.
All right. So just take any part of your body, your legs and your arms, take the cross-section, and that tells you how big your muscles are. And when you say have big muscles, you're measuring sort of circumference, okay?
Right.
And that's related to the...
That's always the way you measure
the circumference of the earth, okay.
Right.
So as you get bigger, your strength will grow as the area of your muscles.
Right.
The cross-sectional area of your muscles.
Okay.
However, your weight goes up as the cube of those dimensions.
Oh my goodness! Of course, I knew your weight goes up, but I didn't realize it. Wow, that's a lot.
That's okay. So that's why, a 300-pound person does not look all that much bigger than a 200-pound person.
Right.
Okay, they're chubbier and they're big. If they could be tall, whatever. But if you start increasing depth, height, and width,
right,
your volume, as your volume increases, so does your mass. But your strength necessary to sustain that volume and that weight does not go up in proportion.
Right.
So your limbs, if you're going to hold up a heavy animal, your limbs have to be much fatter than they would otherwise be if you were smaller. And what are your heaviest animals on Earth?
Your elephant, your whale.
Elephant. Well, on Earth's surface. The elephant. The elephant. Its legs are huge.
Yes.
Okay? They don't have spindly legs.
No, they
Their
don't.
legs are huge. to compensate for the fact that strength only goes up as the area of their muscles, while the weight is going up as the volume. And volume rapidly outstrips area. Okay? Now you can go the opposite direction. As you get smaller and smaller and smaller, the weight with your volume gets lower and lower and lower, and the strength of your limbs becomes better relative to your body weight.
That's why an ant can lift, what is it?
Not only is it why they can lift things relative to their body weight.
Relative to the body weight.
Okay, all right. It's not only can they do that, it's why they can get around with really skinny legs.
Right.
Okay, yes, they have 6 of them, but they're really skinny compared to the thickness of their body, because the legs aren't holding up much weight relative to their own strength.
Right. So and they intermittent fast. They do intermittent fasting too. So.
Oh, is that how that works? Thank you.
I don't think so.
Go to an ant colony, they have these diet books.
Wow. So you know what? You just gave me a really stark thought, which is I watched this documentary about this guy who climbed the only cliff face that these people die all the time climbing it without any belay. And this guy was super skinny.
Yep.
Not strong, like with big giant muscles, but I mean, his muscles, when you look at his musculature, this dude was ripped.
He's ripped, but he doesn't weigh very much.
But he doesn't weigh much at all.
Correct. And that's why in the movie Cliffhanger, which involved rock climbers and mountain climbers, it starred Sylvester Stallone, who's got all these muscles. It's like, no! Every mountain climber on Earth knew that is not the body type, because he's got muscles where he does not need them. He's got body mass that is counter to his ability to support himself.
Right.
So the point is, generally, and there's certain exceptions depending on environments, the smaller you are, the less you weigh, the thinner your legs can be and still hold up your weight. And the bigger you are in mass, the thicker your legs are. So rhinoceroses and hippopotamuses, hippopotami and elephants all have really thick legs. Because as they got bigger, if they kept their thin legs, they break their legs. And that's the end of you. You get eaten, and that you leave the gene pool very quickly when that happens. Okay.
All the lions are missing you.
Okay.
Like, remember those elephants with the skinny legs, man? And we used to just find them lying around. Oh, they made such a delicious meal. Remember those days? We would just walk out on the plain, and we would find
the elephants on crutches because they kept breaking their legs. Right. So anyhow,
snap.
So that's why you don't find very tiny creatures with really thick legs. So because they don't need it. That's the point. Okay. So now that's a important fact number 1. Okay. Whales are different because they don't weigh anything.
Right.
You got to go back to our weight density and whatever.
I was just about to say.
Did we talk about that? I think we talked about that.
No, we didn't. But they're buoyant because they're at a certain depth, and that
right. And so they don't have to hold up their own weight. Right. That's why they can get so big.
Right.
Okay. So it's not fair to say how much is that? Well, it weighs 400 tons. No, it doesn't. It weighs 0 because it is neutrally buoyant in the water. And if you bring it onto the land, it will die because it cannot hold up its own weight. It cannot do anything in its own weight. So you cannot say it weighs that much because that's not where it lives.
It makes so much sense because you've never seen a beach whale say, all right, I'm out of here. I'm good with the land thing. I tried the beach. Now I'm gonna roll myself back on in here. I'm good. You never saw that.
You never saw that. So they don't weigh anything. They don't have to hold up their own weight. So they're really not. So everything I'm describing is sort of in the air on Earth's surface. Okay. Right. All right. So, but I'm not done.
Oh, cool.
Not only that, the laws of physics don't all manifest equally at all size scales.
Interesting.
Okay, so If you're going to drink water, you'll put it in a glass and then you'll drink it like this.
Right.
Why do you put it in a glass? Why don't you just sort of pour it in front of you? Well, because it'll flatten out on the table and you'll make a mess.
Right.
Okay? But suppose I am an insect. Again, suppose I'm an ant. Does an ant need a vessel in which to put the water in order for it to drink? No, because water beads up. There's a bead of water that does not continue to spread. It could just walk up and suck the juice right out of the bead of water until it's gone. Okay.
Nice.
Now, the producers and writers of the movie Bug's Life knew this. So when the mosquito went to the bar and ordered a drink, and what drink did the mosquito order? A Bloody Mary, of course. Okay, so Bloody Mary. Positive.
I just turned it to my mother. I can't believe it.
You turned it to your parents. That's right.
I turned it to my parents then. Oh my God.
Okay, so
Bloody Mary. Okay.
A Bloody Mary, O positive. Okay,
Very funny.
and so the bartender, which is another insect, I don't remember what kind, has a spigot, pours out a blob of Bloody Mary and plunks it down in front of the mosquito, and it's just a ball. Okay, held up by surface tension. Surface tension is this imaginary film that exists on the surfaces of liquids that you have to sort of puncture that in order to fall through. But that sort of film actually contains it in small enough amounts. Surface tension is not strong enough to contain a big blob of water like this because gravity wins. But when you're small enough, gravity loses against surface tension. Surface tension wins. They plop this drop of Bloody Mary in front of the mosquito. Mosquito put in its nose, sucked it out, and then that was the end of that scene. This was brilliant, and it's in that movie. It's a Pixar movie. They had people who knew physics and chemistry writing the script for that movie. So different forces operate when you're small than when you are large. And so that's why there's something called, is it a Jesus spider? A water strider, sometimes called, there's something that walks on the water swiftly, and in some regions they call it a Jesus spider, I think. Anyway, because Jesus in the Bible walked on water. Well, except Jesus weighs more than the surface tension would have held him up. So Jesus would have just sunk without some kind of magic or spirit or miracle, okay?
Right.
Whereas if you're small enough,
or maybe he had just giant foam sandals.
We didn't check.
He was right. He was the first person to wear the giant foam sandals. And they're just like, oh my God, Jesus, it's a miracle.
But people misinterpreted it, right?
Right. They were like, hey, but go ahead.
So all I'm saying is that if you're small enough, that surface tension, you don't weigh enough to break the surface tension. Right. So then you can just sort of walk on the water as some insects do. So my point is, size is everything in this world. And you might say, well, could you have something really big, like a life form the size of a galaxy? Probably not. Here's why. Because suppose you're that big. By the way, the galaxy is 100,000 light years across. Suppose you have your head itches, and then you send the signal to the brain, and then it goes to your finger, and you got to bring your finger up to scratch your head.
Well, that took about 30 million years.
It's going to take at least 100,000 years to get your arm to your head, moving at the speed of light. And you're probably not moving at the speed of light. So you're not going to be able to respond to stimulus the way life needs to in order to thrive in an environment. So there's certain sizes above which are not realistic. Wow. So physics contains the largest and the small. And by the way, you can't be so small that quantum physics prevents your molecules from binding. You can't be smaller than the sizes of molecules.
Right.
Because what are you at that point? Okay? If molecules comprise life, you can't be life that's smaller than a molecule. It's just not, there's no... So the chemistry and physics contain all the realms in which you will find biology. And that's just the beginning of it. I'm giving you the basics of it, where that's the entry level sort of size and life 101. So there you have it. So Spider-Man, he's got the powers of a spider? No,
right.
Not if he's that size.
Nope.
He doesn't.
No, he doesn't.
No, he doesn't.
Right.
No, he doesn't. He can't. No.
Right. He basically just has the powers of a really good rock climber.
Rock climber. Yes.
That's about it.
That's about it. All right, we got to go there.
All
Chuck,
righty.
good to have you.
Always a pleasure.
Neil deGrasse Tyson signing off, bidding you keep looking up.